Okay, so this first question, not too bad. There's 55 students. Of those surveyed, 20% responded they intend to enroll. Based on this study, which of the following is the best estimate for the total number? So this is, pretty much get your calculator out. And what is 55 times 0.22 or 0.20? Sorry, 0.20. And so you get 11 students. This next one, oops. Jay walks at a speed of 3 miles per hour and runs at a speed of 5 miles per hour. He walks W hours and runs for R hours. And so for a combined total of 14 miles. So which one is the correct answer? So my first thought is I always used, the DIRT equation, distance equals rate times time. It looks like there's a total of 14 miles. So we might be adding up the distances here. So distance 1 plus distance 2 equals the distance total is kind of the framework we're setting this up with. And so again, distance is rate times time. So the first one would be 3 times, I guess that's walking, right? So 3W plus the second distance is 5 times running, or 5R. Equals a total of 14. So something like that. And so that's the way they set it up. And so you could have used X and Y, but I saw they used W and R there. Okay. This one, let's see, put this away for a second. So here's a scatter plot. Can you eliminate which of the following best represents the line of best fit? So right away you can see the this is 0 right there. So because that's 0, the y-intercept is definitely a positive number between 2 and 4. So let's see. So y-intercept is definitely not a negative number. So I think these two are out. The slope is definitely positive. So it's got to be one of these guys. It can't be one of these. So it's definitely going to be A. Not too bad. Just again, eliminate is a great way to go on some of these problems. Number 4, again, they love this question on the new digital SAT, and so just be prepared for it. It's saying when x is 0, which means what's the y-intercept, which you can see is positive 3. It's almost too easy. Okay, number 5. Okay, so we have an expression here where m and q are positive. Okay, so we're just kind of multiplying the m's. I like to do as little work as possible, so I'm going to look at just the m's. So it looks like we have m to the 4th times n to the 1st. So if you remember your exponent rules, which I hope you do, you're going to add those exponents, so the m will be m to the 5th. Look at that. I'm done with the problem after just doing the m's. I didn't even have to go to the q's and z's. Amazing. Okay, 6, what is the median? So are these numbers written in order? They are. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 divided by 2 is 4.5. So 1, 2, 3, 4. Right. So the 5th term should be in the middle, right? So I round up. So there's 4 to the left of that term. There's 4 to the right of it. So 79 has to be the median or middle term there. Boy, this one's a tough one here. So just subtract, so we get x equals 55. Almost seems too easy there. The easy ones are really easy. They don't worry, they get hard. Like this is, it'll get hard. It'll get difficult. Okay, so x equals 3. And then this one, so once x equals 3, now we can plug that in. So if you plug in a 3 right there, that's negative 12 plus y equals negative 2. And then you're going to add 12, so you get y. Let's see. So x equals 3, so negative 12. Plus y. So if we add 12, we get y equals 10. Oh, I was like confused because I thought I don't see 10 on there. But they don't ask for x, they ask for x plus y. So x plus y would be 13. Perfect. Next one, number 9. Again, these start kind of on the easier side, but they'll get more difficult. So Given the function, GE models the number of gallons from full tank of gas driving m miles. According to the model, about how many gallons are used to drive each mile. So each 1 mile here. So think of G is the number of gallons. So this is like gallons. This is the number of miles. And so the slope here is, according to the model, about how many gallons of gasoline are used to drive each mile. So you might think of the slope as negative 0.05 divided by 1, where 1 is the number of miles, and this is the number of gallons. So every time you drive one, it helps to think about slope with a meaning on this test. And so every time you drive 1 more mile, you lose 0.05 gallons of gasoline. And so according to the model, how many gallons of gasoline are used to drive each mile? It's asking about the slope, basically, in that case. This next one, given equation relates to the positive numbers, okay, which of the following correctly expresses x in terms of b and y? Part of the reason they say positive, in case you're curious, they don't want b or y to be 0, because that would make the whole thing undefined. So they're just restricting it to those kinds of values here. So it looks like they're solving for x. I guess I'm going to cross multiply here. So y equals 7 times 11 is 77 bx. Divide by 77b. And you get x equal to, all these are x equals, and so it would be y over 77b, which is c. So just a little bit of it's called a literal equation where you're using, solving for variables. This one's not too bad, right? So plug in 76 right there, so you get 76 equals x squared minus 5. I'm going to add 5 to both sides to average that. So 81 equals x squared. Take the square root of both sides. So x is plus or minus 9. What is the possible value of x? Well, one of the possible values is negative 9. Okay, y is bigger than 14. And so this is kind of interesting. I think I'd probably just plug in 14 there and see what happens. I think that's probably a good plan. Subtract 14, you get 4x is less than 4. Divide by 4, so you get x less than 1. Which value could be, so we know x is smaller than 1. So that's, oof. So how do you do this? Well, so I think these two are out, right? If we did it that way. So we plugged in a number bigger, like we plugged in 20. That would be a negative number over here. Okay. I don't know what I was doing here. I didn't even read, you should probably read the question. It says y is 53 right here, right? So y is 53. Guess what I should plug in for y? Maybe 53. I think that would be a good plan. So 4x plus 53. It helps to carefully read the question. Sometimes we just start working with what we got there and see how it plays out. And it doesn't always, not always the easiest way to do it. Okay, so you can get your calculator if you want to, and you can type in 18 minus 53 is negative 35, so less than negative 35. Okay, so then we're going to divide by 4. So if we want to divide this by 4, so divide by 4, you get negative 8.75. So x is smaller than negative 8.75. I was able to eliminate 2 answers doing it the other way, at least get that far. The only number that works there is a. Plug it in for y. Okay, so about 25% of the questions are going to be these gridded responses. So get used to them. About 25% of the questions can be like that. So out of the 300 seeds that were planted, 80% sprouted. How many of those seeds sprouted? So this, again, kind of similar to the other question, 300 times 0.8 is 240. And so you just type that in as your answer. The function is defined as f of x equals 4x. So for what value of x does f of x equals 8? So I would think x equals 2. So 2 would be your answer there. And did you all follow that? It's just what value would make that 8? 4 times 2 is 8. Which expression is equivalent to this guy? Okay, so it looks like they've done some stuff here. Maybe they distributed up top. So you could distribute up there. So if you distribute that, you get 8x squared minus 56x minus 3x plus 21 all over 2 times x minus 7. So let's see what simplifies a little bit up there. So we have 8x squared minus 59x. It's not a friendly one. Plus 21. Whew. All over 2 times x minus 7. Okay, so I guess we could try to factor that guy. Man, that just seems like too much work. Maybe we should have just tried to do this in a calculator and see what happens. It does say that x is bigger than 7 here. That's just trying to avoid, I think, the denominator being equal to 0 there. The purpose of that. So I'm just going to type this in and see what happens. 8x. I like to put the implied multiplication in there when you're working with Inspire. X minus 7 minus 3 times x minus 7. Oh, there was a faster way. I should have looked for it. 2x minus 14. We'll come back to that one. Okay, so let's see what happens if we try to do that. Well, it says 8x minus 3 over 2. That's not bad, right? If you want to do it that way, it's not bad. My first way, and this happens in math, like don't feel bad, this happens to all of us. Sometimes we're like, oh, that just seems like too much work that way. If I had seen the shortcut, do you all see that shortcut? So I have 8x, x minus 7s, minus 3, x minus 7s. I'm going to factor out the x minus 7. So the numerator is going to become x minus 7 times 8x minus 3. Remember, the denominator, when we factored that one, was 2 times x minus 7. Well, now you see the x minus 7s cancel, and you get 8x minus 3 over 2. That's actually pretty high end there, if you want to do it that way by hand. Again, I'm fine with doing it by hand if you see the shortcut. This, doing it by hand, I mean, I guess you can. And some of you are pretty fast at factoring that and, getting there, but man, that's a lot of work. I would consider using the calculator there if you don't see that shortcut. Okay, so this one, let's see what it says. So exponential, you got to be good at exponentials, that's for sure here. So if you just think about the graph here, like 8,000, this is growing. No, sorry. 0.65 is smaller than 1. This is exponential decay, but this value is 8,000. I don't know if we need it. I haven't read the question yet, but it's definitely going down. It's definitely has an initial starting point at 8,000 there because that's the way the equation is set up. So the number of coupons a company sent to the customers at the end of, I love this, each year, and where T represents the number of years since the end of 1998, from 0 to 5 there. So when f of t is graphed, which of the following is the best interpretation of the y-intercept of the graph? So it's at 8,000. What does that 8,000 represent? Okay, so time is a number of years since, so that's 1998. That's in 1998 is the time there. 1998 is the time. The estimated number of coupons the company sent to the customers at the end of 1998 was 8,000. Models the company, yes. So that it does seem like D makes a lot of sense there. That's what's happening. Okay. 18. So you got two triangles. So I might just going to draw. So I'm just drawing a triangle. I don't know what the triangle's like. So let's just say X, Y, Z. And then there's a similar triangle. So similar R, S, and T. and they're similar to each other. So Z is 20, so Z is 20, so this one's 20, which means this guy must be 20 because I drew them in a similar way. XYZ, RST. It says that 2 times XY is equal to RS. Is RS. Oh, so this is 1, then RS is 2, if that makes sense. Right, so it's a 1-to-2 ratio. What's the measure of angle T? Oh, I already answered the question. I should probably have read that first. That other part was just silliness. Okay, they're similar triangles, right? So it says they're similar. That means the angles are the same, and it's going to be in that same order. So T is the last letter there, which is going to be the same as the angle Z. So it's got to be 20 degrees. So it's almost a little easier than I thought it was going to be there. They will get hard, I promise. Okay, so this one equation has 2 linear equations. One of the equations is a system of 2. The system has no solution. So no solution means, we've got the same, if you think about it graphically, we've got the same slope, whatever the slope is, but different y-intercepts. That's really what I want. So if you do this one, it's going to be, if you solve for y equals 6x plus 18. Well, that has an infinite number of solutions. It's the same equation. We want no solution. We want different y-intercepts. These 2 equations would have the same y-intercept of 18. So I do need a slope of 6. So I like that part of it. So I don't like these. It's got to be B, right? It's 6x plus 22. Well, 22 is different than 18. So those would have no solution. Same slope, no solution. Which is fine given system of equations is xy. So what is the value of x minus y? Okay. So I don't know if I see a shortcut. You could multiply the top equation by -4 to solve this. So you could, you get -4y equals -16x minus 4, and this would be 4y equals 15x minus 8. If you add those up, you get 0 equals -1x minus 12. So x equals -12. Okay, so we're getting somewhere. Okay, so then we could plug that in. If x is -12, it's -48 plus 1 is -47 for y. So it would be x minus y, so -12 minus -47. So -12 minus -47, I believe. Which is like plus 47. Get 35, which I think is the answer. Now, could that have been faster with the calculator? Maybe, right? So you could go to menu. Again, I'm just showing you both ways. You have to decide what's fast for you and which way you want to go here. So it seems easy to solve, go for it. So we have, it defaults to 2 equations, x and y variables. You can type it in just like that, so you don't have to solve it. Y equals 4x plus 1, 4y equals 15x minus 8. And so you get those same 2 answers, and then you, by the way, what does the thing x is and y? It doesn't know, just making sure. I wasn't sure if it saved it. And then you just subtract those in your calculator. How many distinct solutions does this equation give? So I really like, you remember the quadratic formula, so x equals the opposite of, x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. That's the quadratic formula. This part of it, underneath the radical, is this b squared minus 4ac. If it makes sense, if that's a negative number, you'd be taking the square root of a negative, you get no solutions, no real solutions, you get imaginary solutions. If it's positive, you're going to get 2 solutions. If it's 0, you get 1 solution. So if you have a quadratic, those are the 3 options, 0, 1, or 2 solutions. So really, that's a silly answer. Like you can just cross it out. It's a quadratic. It's going to have 0, 1, or 2 solutions for this quadratic. Okay, so we don't have to find the solution, so you don't have to factor it. So you could just do b squared minus 4ac and just see if it's positive or negative or 0. So so you do b squared, which would be 100, or 10 squared minus 4 times a, which is 5, times c, which is 16. So you do 100 minus whatever 20 times 16 is. 100 minus 20 times 16 is negative 220. It's a negative number. All I really care about is that it's negative, so negative 220. Because it's negative, you're going to have no real solutions. You're only going to have some imaginary solutions. So there is actually 0 real solutions. We wanted real solutions. That's a negative. If you think about it in the context of this, you're squaring a negative number. When you square a negative number to solve that thing, you're going to get imaginary answers. Stern Park has an area of 11,000. By the way, have you noticed they don't have any problems with like where they're grouped, where you have a paragraph with some tables and data, and then they ask 3 questions about it. They don't do that here. Not going to happen. Stern Park has an area of 11 million acres. What is the area in square miles of this park? So we have to do some conversion. Think about chemistry class, right? So here's the number. Oops, 863. 808. So that's measured in square yards, or yards squared. So I want to convert that to square miles, right? So I need miles squared. So I need yards squared down here, miles squared up here. And so it looks like 1 mile is that many yards, but because it's a squared thing, I think you might square it, right? So let's see what happens here. So I think that's how dimension analysis works on this one. So hopefully chemistry, I barely remember, hasn't failed me here. So you've got basically 11, 863, 808 divided by 1760 squared. And oops. So we get 3.83, which is the answer, right? So we get 3.83. That's great. Okay, we get to the last ones. The test progressively, supposedly, gets more difficult. So you can expect these to be more difficult. If you've had all of Algebra 2, maybe a little pre-cal, you might be just fine. So which of the following equations represent a circle? So hopefully you remember the formula, just reminding you of it. You probably remember this: x minus h squared plus y minus k squared equals r squared. So what's the question asked? It intersects the y-axis at exactly 1 point. Ooh, it's kind of a weird question, right? So these all have a radius of 4. So I kind of want, do you see how the radius is 4 for all those? Okay, so because r squared is 16, the radius is 4. So I really want, I think I found it, right? It's got to be C. Because you go 4 units to the right, in this case, and 9 units, y minus k is upwards. Because the center of that one would be 4, 9. So we get 4 to the right and 9 up. So because 4 is 4 units from the axis, that point, if this makes sense, if I were to graph this somewhere up here, and the circle would look like this, and it's just going to barely touch right there. 4 units away. That's a distance, a radius of 4 right there. Okay, that one wasn't too bad. Okay, so let's see. Again, let's just see. So triangle ABC have measures of 27 degrees. B and E each have measures of 27. Okay, so B and E. Okay, so those are similar. So they're both 27. C and F have measures of 41. Okay, so one of these angles looks like B and C are both acute, so A must be up 2. So I'm just going to draw that just so I have one that's maybe somewhat similar. So B and C. So just so I can label it. So B is 27 and C is 41. If I do another kind of triangle that's similar, this would be DEF, so DEF in that order. It says that E is 27, so that was 27, that one's 41. I mean, they both look exactly the same, right? Which of these pieces of information is sufficient to determine whether triangle ABC is congruent? Okay, so we know that the angles are all the same. Do you agree with that? Like, we could do 180 minus that to get that. So the angles are the same, so they're at least similar, right? We know that the angles are the same because we had 2 of them. We know the third one's the same. It's triangle at the 180. So we don't know if one's bigger than the other yet. So we need the length of sides BC and EF. BC would be this one. EF is this one. Yeah, if we had that, if they're the same, they're congruent. If they're not the same, they're not congruent. So it's got to be that C there. We just don't know if they're congruent or not. Okay, so 26. Okay, so a little stat problem here. 2 data sets of 23 integers each are summarized in the histograms shown. For each of the histograms, the first interval represents frequency of integers greater than or equal to 10, but less than 20. The second interval represents a frequency of integers greater than or equal to 20, but less than 30, and so on. Okay, so what is the smallest possible difference between the mean of data set A and the mean of data set B? That's a really weird question. I'd say we've just upped the level of difficulty a whole lot right now. So what's the mean going to be? Oof. We don't know what the numbers are exactly. We know that each one has 23 numbers, right? We could probably find the median if we wanted to. So I don't know if that'll help, but there's 23. So the 23 divided by 2 is 11.5. So the first 3 terms are here. The next 4 terms are here. So that's 7. I need the 12th term essentially. So the next 7 terms are here. So that's 14. So somewhere in here is the median. Okay, and it's skewed left, which means the mean is smaller than that. So I know the median is on the smaller side of wherever the median is, which is between 40 and 50. So, but still, maybe the median's 50. We don't really know exactly in there. If we added these up, 3, 4, is this the same? 7. No, it's the same. It's just been moved over, isn't it? Oh, looks like. So this one starts from 20 to 60. This one goes from 10 to 50. Huh, they look almost pretty similar, but we don't know what the numbers are inside of there. Smallest possible difference between the mean of set A and the mean of data set B. So again, the median would be in here. The mean's going to be a little bit left of that. So, boy, how do we prove this? So 10 is possible, right? It's possible there's 10 away. Like it almost looks like if they're the same data set moved over, it'd be about 10 away. But it says what's the smallest possible? I don't think they could be the same. Does that make sense? Like I think 0 is gone, and I think 23 is just silly. So 10 is possible. I'm pretty sure 10 is actually somewhat likely. But could it be smaller than 10? I think it could be, right? It's very possible that maybe one of these is on the more of the right side here, or let's see, more maybe on the right side here, and the other one, somewhere. Yeah, that's possible that it's less than 10. So of those choices, I'm going to choose one. Maybe there's a better way to prove that, but I would just think it through. But because we don't know what each data value is in each of those bars, We just don't know. We don't have, if we had the dot plot, or we might be able to figure it out at the mean, but we're just kind of guessing at the mean here. So I don't think that's the way to go. Last question. Right triangle has legs with length of 24 and 21. So right triangle, 24 and 21. I drew that a little bit backwards, but you get the idea. If the length of the triangle's hypotenuse can be written in the form 3 times square root of d, where d is an integer, what is the value of d? Okay, so 3 could be divided by all of them, I think, if that would help us. I don't know if that helps us. This is my first thought. 8, if we divide by 3, 7. This would just be square root of d. Ooh, that's interesting. But I don't know if we can do that. That's a proportional triangle. So that'd be 8 squared plus 7 squared. So 64 plus 49 is 113. So D could be 113. I think that's probably the answer. Could you do this in the calculator? So let's try. Okay, so let's get our calculator out. So let's do Pythagorean theorem with what we were given. I was just trying to simplify it, make it easy. So if we do 21 squared, I don't know what is going to happen here, plus 24 squared. We get that. I guess we take the square root of that guy and see what happens. So square root of that would be our hypotenuse. And it's 3 root 113. You can do it in the calculator, so it's pretty nifty. If you just do Pythagorean theorem, you can find out what that value is. The calculator is going to nicely simplify it for you. Really nice use of the calculator there. You could think through without using the calculator for sure. But again, when it's helpful, you might want to do that. Another thing here, you could, I thought about 24. You could actually just graph that in your calculator if you wanted to. If you forgot how to do that, it's just something you don't always think of, but if you wanted to just graph these guys. So if you hit delete or delete backspace or delete key, and you a relation here, so you could type in that x minus 4 quantity squared plus y minus 9 quantity squared equals 16. If I type that in right, and if you kind of grab the graph and move it down, control center, click this grab, and you can see, you can really see it crosses, it just barely touches the y-axis at one point, which is, I didn't notice it was y-axis, I just saw it axis. That's good that it said that, so you'd have to move the x value for you. This one would move, it would only touch the x-axis at one point, so yeah, pay attention to stuff like that. That's really easy to miss little details like that. When you're going through this, any other calculator things, we did this mostly some by hand here. Maybe it says no solution. So you could solve that system right here if you wanted to. So if you wanted to, what's going to happen actually? So let's just try this. So if you did solve that system, so and this wouldn't be too bad to do, I think. Menu algebra. Solve system, right? Just solve system equations, do x and y. First equation is guaranteed. The second one, you'd have to keep changing. Y equals 6x plus 18. The second one, we're going to type in what we think it is, negative 6x plus y equals 22. What's the calculator going to tell us? I'm curious. False. So instead of saying no solution, it says false. If I copy and pasted that and changed it to be 18, what would the calculator tell us? Interesting. So because I want you to know what the calculator comes up with. If you do use a calculator method, you get one of these weird answers. Like we think that's going to be infinite solutions, or at least in Algebra 2, we'd say infinite solutions. In pre-cal, you might have a way of actually describing that equation or that line a little better. similar to this way. They might not use the same variables there, but when you get that C1 in there, that means there's an infinite number of solutions. You have to define one of them and do that. Sometimes you use a different variable for that, but that's the idea of that one. Again, I don't know if we ever even did this on this one, but we could have. If you look back at 22, we could have solved that with a calculator, right? So maybe that might have been faster. Menu, 3, all the powerful commands are in algebra there, so solve. So we could just type in 5x squared. I don't think we did this, plus 10x plus 16 equals 0. Comma x, don't forget to say that the variable, whoops, comma x, so comma x. And it says false, which means it doesn't have any real solutions there, so there would be 0 real solutions. So again, the calculator will give you some somewhat funny answers when you try one of those. And again, this one as well, you could have solved that system in your calculator, and I think we did do that one. And you certainly solve it just like we just did. Any others here? I mean, I guess you graph that. That's not going to help that much. This one, we talked about it. As far as the literal equation one, where was that one? Let me see. Did I skip that one? I think I skipped that one. So, sorry, I skipped 16. Let me get that one. So solve for y. So, what is the slope? So you could just solve for y. This is an example of one you could, if you have trouble solving that one for y, you could just say solve, 2y plus 18x. Of course, you just did it by hand as well. Equals 9, comma, but solve for y. And it should solve it, right? So -9 is the slope, -9x there. So what is the slope of line r? Wait, did I read the whole question? No, the slope of the original one. So let me just write this down. So the slope of the original problem is -9x plus 9/2. It helps to read the question. So perpendicular to that. So if that slope's -9, the perpendicular slope would be the opposite reciprocal. So you change the sign to positive and you flip it. So it's going to be 1/9, and that'd be the slope of the perpendicular there. Seems like there was another literal equation down here. So you could solve this one. So number 10, I think you could, if you wanted to, solve that. So you could go to solve, and then you type in the fraction 1 over 7b equals, control divide, 11x over y, comma, we're going to solve this guy for x. Yeah, that works. So you could definitely do that in your calculator. Again, it depends how strong your algebra skills are, if you'd rather do that in the calculator or not. But those are some problems that you could, if you wanted to, do them in your calculator. Again, even this one you could. Even this one, like number 5, you can actually just type that in your calculator. It'll take care of business. It'll do it all for you. So if you'd rather do that, if you get a little confusing about the exponent rules, it wasn't so easy as you just had to do the m's and you're done. You didn't have to deal with negative exponents, right? You'd add the -1 plus 3 to get z squared there, which is where that z squared comes from. Okay, I think that's pretty good. So that's your lesson. Thanks for staying the whole time here, and hopefully you learned something new. And again, just get used to these kinds of problems. The more practice you do on this digital, the better you're going to be for the test here, the PSAT. I really have high hopes for you guys to really do well on that test. Practicing these tests, I'd get out that linear practice test number 3 and try that one. Do the rest of that one for if you come to that optional session, that's what I would do. One last thing is if you have the Blue Book app. So like I have the Blue Book app here. I'm going to pull it up and see if see what happens. I don't think I've updated mine, by the way. So what I'm asking you to do is make sure your app is updated. They did a little update, I think, on the 21st. So if you haven't pulled it up before, after that time, it's going to have to check for updates. It's going to be downloading the updates. You want to do that before test day. You don't want to have to do the update during test day. So just kind of open it up. It'll probably tell you once it's all installed, say, hey, you're good to go now. But don't wait until test day to do this, because who knows what the internet's going to be like. There's going to be some glitches. It could be, I don't know. So just make sure you update now. So do that while you're thinking about it. Do it right now. And that is my advice for you. Thanks.